Flame Among the Stars. A Sleep Story from Mir. Opening, Evening Light. February 23, 1997. 9:37 p.m. Moscow time. 250 miles above Earth's surface. The Russian space station Mir drifts through orbit. Graceful. Patient. A small city of metal modules connected like pearls on a string, catching the last rays of sunset as it glides over the darkening Pacific. Inside, 6 people float through their evening routines. Dinner finished. Cleanup done. The quiet time before sleep. Commander Valery Korzun moves through the Kvant 1 module. Checking systems. Monitoring. The steady rhythm of station life. His crewmate Alexander Lazutkin prepares to change an oxygen canister. A routine task, done thousands of times. Simple. Safe. The canister, about the size of a spray paint can, contains lithium perchlorate. When ignited, it burns slowly, steadily, producing oxygen through chemistry. Each one provides enough breathable air for one person for one day. Tonight, with 6 people aboard during a crew handover, they need the extra oxygen. Lazutkin opens the panel, removes the old canister, slides the new one into place, presses the ignition button, and a 3-foot jet of flame erupts into the module. White-hot, brilliant, shooting sparks and molten metal across the narrow space. This is the story of fire in orbit, of smoke filling a place where you cannot open windows, of calm voices in impossible circumstances, of teamwork when panic would mean death. But it's also a story about something quieter, about how humans adapt, how systems evolve, how one terrifying night teaches lessons that echo across decades. Let yourself drift with us now, into orbit, into the flame, into the gentle unfolding of a crisis that changed spaceflight forever. Chapter 1. The Nature of Fire in Orbit. On Earth, fire rises. Heat makes air expand. Hot gases become less dense. They climb, pull fresh oxygen from below, create the familiar teardrop shape of flame. But in orbit, in microgravity, fire behaves differently. No up, no down, no buoyancy, no convection. Flame becomes a sphere, perfect ball of combustion, blue-white at the center, orange at the edges, fed not by rising currents but by diffusion alone. Oxygen molecules slowly drifting toward the heat. This makes fire in space both more dangerous and less dangerous than on Earth. Less dangerous because it spreads slowly. Without convection, flames can't leap, can't race through compartments. They burn where they start. Patient, almost lazy. More dangerous because smoke doesn't rise. It doesn't clear. It fills every available space, creeps into corners, hangs in the air like fog. And in a sealed metal tube orbiting Earth at 17,000 miles per hour, there's nowhere for that smoke to go. This is what Lazutkin faces now. Not just flame, but the physics of fire transformed by the absence of gravity. The canister burns, spewing molten droplets, the metal casing itself beginning to glow, and smoke, thick, chemical, toxic, begins to spread. Chapter 2. The First Response. Korzun moves instantly, not with panic, with purpose. 20 years of training. Fighter pilot, cosmonaut, commander. His hands know what to do before his mind finishes thinking. Fire, he calls out. Calm, clear. The word every crew member dreads. Jerry Lininger, American astronaut, 3 weeks into his stay aboard Mir, hears the call from the base block module. He pushes off, floats toward Kvant 1. But the smoke is already spreading. Dark, acrid, burning his eyes. The crew grabs respirators, masks that fit over nose and mouth. Small oxygen tanks built into each one. 15 minutes of air. Maybe 20 if you breathe calmly. Some of the masks are old, poorly maintained. They put them on. Turn the valves. Nothing. No oxygen. They try others. Finally find ones that work. But now visibility is near zero. The module filled with smoke so thick you can't see your hand in front of your face. Korzun positions himself at the hatch. One person can fit. Only one. The space too narrow for more. He aims a fire extinguisher. Foam. Water-based, heavy, sprays. The foam hits the flame. Steam erupts. More smoke. The fire dims, but doesn't stop. Behind him, Lininger holds his commander's feet, anchoring him. In microgravity, pushing forward means drifting backward. You need someone to hold you in place. Someone passes a second extinguisher forward. Corzin empties it, then a third. All the while, the canister burns. The flame a blowtorch now, 3 feet long, cutting across the module, blocking access to one of the 2 Soyuz escape capsules docked to Mir's far end. If they need to evacuate, if the hull breaches, if systems fail, 3 crew members won't be able to reach their lifeboat. But Corzin keeps spraying. Methodical, patient, covering the walls with foam, protecting equipment, preventing the fire from spreading. And finally, after what feels like hours but is really only minutes, the flame dies. Not extinguished by the foam, just finished. The canister's fuel consumed. Silence. The only sound. 6 people breathing through masks, hearts pounding, smoke thick as wool. Chapter 3. The long clearing. The fire is out. But the emergency isn't over. Smoke fills every module. Kvant 1. The base block. Spectre. Crystal. Everywhere. And it's not ordinary smoke. It's chemical. Toxic. Lithium perchlorate combustion produces fumes that burn lungs, irritate eyes, make thinking difficult. The respirators have limited oxygen. 15 minutes per person. Maybe less. They need to clear the air. Fast. Mir's life support system was designed for this. Scrubbers. Filters. Fans pulling air through activated charcoal. Removing carbon dioxide. Removing contaminants. But it takes time. The system wasn't designed for smoke this thick, this toxic. The crew works together, opening valves, adjusting flow rates, maximizing circulation, and they wait. 1 hour passes. The smoke thins, slightly. 2 hours. They can see shapes now, outlines. 3 hours. The air becomes breathable, just barely. They remove their masks, breathe cautiously, eyes watering, throats raw, but alive. All 6. No injuries, no casualties. In the darkness, in the chemical haze, they float, exhausted, shaken, but together, safe. Chapter 4. What the fire revealed. Later, after the smoke cleared completely, after the crew slept, after mission control analyzed what happened, questions emerged. Why did the canister fail? These had been used more than 2,500 times aboard Mir. Thousands more in submarines. Decades of safe operation. What went wrong? The damaged canister was returned to Earth on the next shuttle mission. Examined. Analyzed. But the fire had destroyed most of the evidence. The metal melted. The chemical residue burned away. Investigators could only theorize. A crack in the casing. Contamination in the lithium perchlorate. Manufacturing defect. Then, nearly 2 years later, a breakthrough. NASA scientists testing the system found hydrocarbons in some canisters. Organic material. Out of place. Russian investigators traced the contamination back to the manufacturing process. To latex working gloves worn during assembly. Just a small piece. For square centimeters. Enough rubber to contaminate the chemistry. To create an explosive reaction instead of a controlled burn. They reproduced the fire in tests. Confirmed the cause. A torn piece of latex glove. Probably left during assembly years earlier. Waiting. Dormant. Until the night Lazutkin pressed the ignition button. Such a small thing. Such enormous consequences. Chapter 5. The lessons carried forward. The fire changed everything. NASA and Roscosmos immediately began redesigning safety systems. For Mir. For the International Space Station still under construction. They developed ceramic mitigation screens. Fire-resistant housings to contain any future canister failures. To catch molten metal. To prevent flame from escaping. They improved quality control. X-rayed every canister. Tested for contaminants. Eliminated latex gloves from the assembly process. They trained crews differently. More fire drills. Better respirators. clearer evacuation protocols. The lessons from February 23, 1997 became written into the DNA of the ISS. Into procedures, into hardware design, into the culture of safety. Even today, nearly 3 decades later, the same oxygen generation system flies on the ISS. The Vika canisters, the solid fuel oxygen generators, but safer, better understood, with protections learned from one terrifying night aboard Mir. Jerry Lininger later wrote about the experience, about the fear, about breathing smoke, about realizing how fragile life is when sealed in metal, orbiting in vacuum. But he also wrote about the crew, about Corzen's calmness, about everyone working together, about trust. "We couldn't escape the smoke," he said. "You can't just open a window to ventilate the room." But they didn't need to. They had each other. They had training. They had systems that, even when one failed catastrophically, had enough redundancy to save them. Chapter 6. The quiet afterward. Days later, life aboard Mir returned to routine. The damaged panels in Quant 1 were covered. The charred cables wrapped. The scorched equipment replaced. The crew continued their work. Science experiments. Station maintenance. Exercise. Meals. Sleep. But something had changed. Not visible. Not measurable. Just a slight shift in awareness. They moved a little more carefully through the modules. Checked systems a little more thoroughly. Noticed small anomalies that before they might have dismissed. The fire had reminded them. Space doesn't forgive complacency. But it had also shown them something else. That humans can handle more than they think. That panic is a choice. That calm, methodical response, even when flame fills your home and smoke blinds you, is possible. The station continued to orbit, circling Earth every 90 minutes, day into night into day, and inside 6 people floated, working, living, breathing air generated by systems they now understood in ways they never wanted to. Chapter 7. The view from windows. Imagine floating there now, in the restored station, smoke long gone, systems humming quietly. You drift to a window, the cupola, Earth turning below, oceans reflect sunlight, blue, shimmering, clouds cast shadows on continents. Entire weather systems spiral slowly across hemispheres. At night, cities glow, golden clusters connected by glowing threads of highway. Lightning flickers silently in distant storms. And above, stars. More stars than you've ever seen. Sharp, clear, eternal. You're traveling 17,000 miles per hour. But you feel no motion. Just suspension. Just the gentle, constant presence of orbit. Behind you, the station hums. Fans circulating air. Pumps moving water. Computers monitoring. Life support systems doing the invisible work that keeps you alive. The same systems that failed that February night. The same systems that also saved 6 lives by clearing toxic smoke slowly, patiently, reliably. Engineering, redundancy, human ingenuity, and something else. Something harder to name. Trust. In machines. In crewmates. In the slow accumulation of knowledge that comes from failures and near misses and terrifying moments transformed into lessons. Chapter 8. The mathematics of safety. Space stations are built on math. How much oxygen per person per day? How much water? How much carbon dioxide removal? How much power? The equations are unforgiving. Miss by a little and everyone dies. But engineers build in margins. Redundancy. Backup systems. Backups for the backups. The electron system generates oxygen through electrolysis, splitting water molecules. Reliable, efficient. But when crews grow larger, when 6 people occupy a station designed for 3, the electron can't keep up. So they use the Vika canisters. Chemical oxygen generation. Supplement the electron. Provide the extra breathable air. Each system independent. Each capable of failing without killing everyone. Until that night, crews thought the Vika system was perfectly safe. 2,500 uses. No incidents. Then one contaminated canister taught them. Nothing is perfectly safe. Every system can fail. Even the most reliable. But redundancy saves lives. The station didn't have just oxygen generation. It had life support that could clear toxic air. It had multiple escape vehicles. It had trained crews who knew how to respond. The math of safety isn't about preventing all failures. It's about ensuring that when failures happen, and they will happen, people survive anyway. Chapter 9. The names we remember. Valery Korzun, Alexander Lazutkin, Jerry Lininger, Alexander Kalery, Vasily Tsibliev, Reinhold Ewald. 6 names. 6 people who faced fire in orbit and lived. They returned to Earth eventually. Different missions, different schedules. Some flew again. Some retired. Some became engineers, trainers, speakers. But they all carry the memory, the smoke, the flame, the minutes of not knowing if they'd survive. Lininger wrote a book, Off the Planet, describing his time aboard Mir, the fire, other crises, the collision that would come months later. He became an advocate for safety, for questioning assumptions, for learning from near misses before they become disasters. Korzun continued his career with Roscosmos, flew on the ISS, became a manager, a mentor. The German astronaut Ewald called the experience intensely focused, said it taught him about human performance under stress. They don't consider themselves heroes, just people doing jobs, making decisions, responding to circumstances. But from Earth looking up, they are extraordinary. 6 humans who stayed calm when everything said to panic, who worked together when isolation would have been easier, who trusted systems and each other enough to breathe toxic air and wait for filters to clear it. Chapter 10. The Legacy of Flame. The ISS flies today because of lessons learned on Mir. Better fire suppression, improved air quality monitoring, enhanced crew training, safer oxygen generation. Every astronaut and cosmonaut trained for the ISS practices fire response. In simulators, in underwater training, in classroom scenarios. They know where every fire extinguisher is located, how to don respirators quickly, how to isolate modules, how to evacuate if necessary. They drill until response is automatic, until calm becomes reflexive, because space is unforgiving. But humans are adaptable. We learn, we improve, we carry lessons forward. That February night aboard Mir, terrifying as it was, killed no one, injured no one, made future space travel safer for everyone who followed. The station burned, the crew survived, and humanity became a little wiser about living among the stars. Chapter 11. Drifting towards sleep. Let yourself float now, into the quiet, into the darkness. Not the dangerous darkness, the peaceful kind, the kind that exists after crisis passes, after smoke clears, after breath returns to normal. You're aboard the station. Windows show stars. Instruments glow softly. Systems hum their gentle mechanical lullaby. Everything is working. Everything is safe. The air is clean. The temperature perfect. Oxygen flowing. Carbon dioxide scrubbed away. You float to your sleeping compartment. A small space, just big enough. Walls covered with photos, messages from home, reminders of Earth. You slide into your sleeping bag. Zip it up. The fabric holds you gently. In microgravity, you need something to prevent drifting, to provide the sensation of being held. You close your eyes and feel the station moving beneath you. Not moving, really, just existing. Traveling through orbit, circling Earth. A small bubble of life in the vast emptiness. Outside vacuum, cold, radiation, 1,000 ways to die. Inside warmth, light, safety. The boundary between them, a few inches of metal and insulation. And the knowledge, the accumulated wisdom, the lessons learned from every crisis that came before. Including that night, the flame, the smoke. The calm voices working together. You breathe slowly, deeply. The air tastes clean, fresh, safe, and you drift into sleep, into dreams, into the quiet space where consciousness fades and rest begins. Epilogue. The eternal orbit. Mir burned, not that night, but later, in 2001, deorbited deliberately, entering Earth's atmosphere, pieces burning across the sky before splashing into the Pacific. 15 years of service, more than 86,000 orbits, home to 104 people from 12 countries. It taught us how to live in space, how to work together across languages and cultures, how to respond when systems fail, how to survive fire and collision and near disaster after near disaster. And it gave us the ISS, built on those lessons. Stronger, safer, better. The ISS continues orbiting. 25 years now, the longest continuous human presence in space. New crews arrive, old crews depart. Science continues, life goes on. And somewhere in that orbital routine, in the daily tasks and maintenance and experiments, the memory of February 23, 1997 remains. Not as trauma, as wisdom. Fire in orbit can be survived. Smoke can be cleared. Calm response saves lives. These truths, learned in crisis, guide every mission that follows. The flame among the stars is gone now. But its light, the lessons it illuminated, continues to shine, guiding us, teaching us, reminding us that humans, for all our fragility, carry something extraordinary. The ability to face the impossible, to stay calm in crisis, to trust each other when trust is all you have, and to transform fear into knowledge, danger into safety, one terrifying night into decades of safer spaceflight. So rest now, float gently, let the hum of life support lull you deeper. You are safe, held by engineering, protected by lessons learned. The flame is extinguished, the smoke cleared, the air fresh and clean. And you, small, fragile, temporary, you drift among the stars, breathing slowly, deeply, peacefully, held by everything, threatened by nothing, just floating, just breathing, just being, among the quiet, among the stars, among the infinite patience of orbit. Sleep well, traveler. The station keeps watch. The end. Rest peacefully. The universe has learned to keep you safe.